Hi, welcome to the second to last Advent of Code livestream, where I'm gonna try to tackle today's problem in Go. I don't know what else to say. I will do the same thing I always do. I will look at the problem and then hopefully solve it in the allotted 2 hours or so. We'll see. So let's just dive in. Small crab challenges you, so apparently the same crab I actually don't need these. Apparently the same crab we beat yesterday challenges you to a game. The crab is going to mix up some cups and you have to predict where they'll end up. The cups will be arranged in a circle and labeled clockwise, your puzzle input. For example, if your labeling were 32415, there would be 5 cups in a circle going clockwise around the circle from the first cup. The cups would be labeled 32415 and then go back to 3 again. Fine. Before the crab starts, it will designate the first cup in your list as the current cup. The crab is then going to do 100 moves. Each move the crab does the following actions. The crab picks up the 3 cups that are immediately clockwise of the current cup. They are removed from the circle. Cup spacing is adjusted as necessary to maintain the circle. Fun. The crab selects a destination cup. The cup with a label equal to the current cup's label -1. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. I love this. Again, great rules. The crab selects the destination cup, the cup with a label equal to the current cup. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. Okay, I guess. If at any point in this process the value goes below the lowest value on any cup's label, it wraps around to the highest value on any cup's label instead. Okay. The crab places the cups it just picked up so that they are immediately clockwise of the destination cup. They keep the same order as when they were picked up. The crab selects a new current cup, the cup which is immediately clockwise of the current cup. Okay. For example, suppose your cup labeling were this. If the crab were to do merely 10 moves, the following changes would occur. Okay, we will check that once we have implemented it. In the above example, the cup's values are the labels as they appear moving clockwise around the circle. The current cup is marked with this. Okay. After the crab is done, what order will the cups be in? Starting after the cup labeled 1, collect the other cups labeled clockwise into a single string with no extra characters. Each number except 1 should appear exactly once. In the above example, after 10 moves. Okay, so let's just try to implement it. I think I will not even try to really understand what's going on until I just roll it down. So given that our input now is just like a single short string, we will, instead of reading from stdin, we will just use like a flag. We will just say flag.parse if flag.enarg is not 1, log.fatal hi John. Require arguments, and we will do log.setFlags, log.l short file. This is the same thing I did the last couple days. Just so that we get line numbers when we do debug logging. Flag.arg0, that's the input. And then, we do want them to be integers, so we just say cups. So cups will be a slice of integers and the length will be the same of in. And then we will just say for or each character in or whatever. Let's do this. If the character is not a digit, so if 0 is greater than R, or R is less than, wait, 0 is wrong, it should be this 0, R is greater than 9, that's an error, must be only digits or whatever. Otherwise, we just set cups R to R minus 0. So this will just, this will just subtract the character value of 0 from R, and so this will be a number between 0 and 9. I think this is correct. If we look at the ASCII table, yeah, it's like they are consecutive 0 to 9, so this is fine. So let's just be super duper extra certain. Cannot use this. This makes sense. We want this to be converted to int. Great. And our test input is that, but let's start with the one we have as kind of a test case. Okay, great. Surprisingly, we managed to do this. We also, I guess I also want to check that the digits are consecutive. Like I want to check that they are actually all digits like from 1 to 9 or whatever. Because we want to do stuff like we increase by 1 or like decrease by 1 the label and then wrap around and stuff. So we want to make sure that we know what the minimum and maximum is. How do we do that? I don't know. Let's just say we do like var un32. Like we could sort it and go through it, but let's just do this. Let's just do bit masking. M is 1v, and so one. Let's also say if len cups greater 10, log.fatal argument contains duplicate digits, because obviously there are at maximum 10 digits, so contains duplicate digits. So if we have more than 10 digits, at least one of them must repeat. And now if m is not 1 10 minus 1, so this is a bit like bit shifting black magic, but I hope it's somewhat understandable. So this one is a 1 shifted 10 by shifted left by 10. Then we subtract 1, and this will be a bit mask that has. Wait, maybe we want to shift 11. Like we want to have the lowest 10 bits set. Yeah, no, I think this is right. Log.fatal argument is not does not contain all digits 0 to 9 or whatever. Oh, okay, apparently this is too much black magic, so let's not do black magic. Let's do something less black magic. Yeah, everything else is also ugly. I can't believe that this is where I'm like drawing the line. Var cups to is append sort.ins cups to for iv range cups to. If I is not v, log.fatal argument does not contain all digits 0 to 9. Should you have shifted 9 at the end? I don't think 9, I think 11, but I'm not quite sure right now. And so, like, if I have to think about it and figure it out, it's obviously too obscure. Like, I think shifting 11 is right, because then you get a 1 with 11 zeros. No, it should actually be 1 to 10. Wait, maybe this is just not 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it doesn't contain a 0. That's the problem. Okay, then let's actually... how about this one? Does this contain... This also just contains 1 to 9, right? Yeah, okay, so let's just say... func verify arg cups int. Let's just log.fatal out of that, and then let's do that in a separate function. So because all of this is stupid. And arrow, and like let's also make all of this. Yeah, so we don't actually need all digits 1 to 9. We just need consecutive digits. So we probably don't want 1 0 actually. I don't know, something like this. Yeah, I'm not talking, but whatever. Return cups. So, I think this is fine. Like, all of these checks are ultimately pretty useless anyway, so... because, like, we will just do it once. So, cups air is pass arg flag.arg0. If this is not null, log.fatal. So, okay, now we have our cups. Great. Cannot use this type in. What? Yep. Yep. Okay, this looks. Cups, yeah, progress. Nothing happened. But now we know that we have 9 factorial is far too much to shift. How do you get 9 factorial? Like 9 factorial is enormous. Like I don't have that many bits in my integers, so no. Like yes, that's the number of things. So the logic behind this was, if you look at like in binary, if you look at 1 shifted 10 left, you get like 1. You get this, a 1 with 10 zeros, and then if you subtract 1 of that, you get from that you get this in binary, and so this has like exactly 10 bits set, and like that's the logic behind doing like 1 n minus 1 to get a bit mask that has exactly the lowest n bits set. You shifted 1, then 2, then 3. Yeah, anyway, doesn't matter anymore because I removed the stuff anyway. Now I'm curious. No, I would just ignore all of this and I would just continue doing this extremely difficult and challenging and meaningful problem. So. Okay, it does each move. So let's again do like a func do move cups and Yep. Okay. So the crab does the following actions. I will move this to this workspace and then do it side by side so that I can read and type at the same time. So the crab picks up 3 cups that are immediately clockwise of the current cup. I will decide for now. I think that I will always make the leftmost cup the current cup. Right, so I will just designate that. Meaning the 3 cups immediately clockwise of the current cup is cups until 3. They are picked up, and the rest will stay there. Okay, so pick up the first 3 cups. Done. I do have to be a bit careful because I'm slicing, so if I modify the underlying array, things will change. But I think that's fine. I don't know. I hope that's fine. We will see. Otherwise, I will try to think about it to keep it in mind. Okay, so they are removed from the circle. Cup spacing is as if cup spacing matters for our representation. Anyway, the crab selects the destination cup, the cup with a label equal to the current cup's label -1. The current cup, I guess, that are immediately clockwise of the current cup. So I guess from that perspective, it would make more sense to always make the last cup the current cup, because then taking the first 3 is easier. But that means the destination cup is cups len cups -1. And the last cup, that's the current cup. And now we need to check that the destination cup has not been picked up. So for I0 I less than 3i plus plus. Let's actually write a quick helper to check if a value is in an array, in a slice, and we will just do this inefficiently, linearly, because it's fine. For values in the slice, if the value is the needle, return true. Otherwise, return false. So, and actually we don't even need that. We can just say for in picked up the destination cup. As long as the destination cup is in the picked up cups, decrease it by 1, and because there are only finitely many picked up cups, we know that this loop will just terminate after 3 rounds, and that's fine. Now we have a destination cup. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. If at any point in this process the value goes below the lowest value on any cup's label, we should say this makes sense. This goes below the lowest value on any, so dest minus if dest is less than 1, dest equals 9. Of course, we've just for now said, well, let's just say it's 1 to 9 always. To the highest value on any cup's label instead. Like we could also do like modular arithmetic, but modular arithmetic in Go is a bit... No, I'm not gonna say that. To the highest value on any cups labeled instead. The crab places the cup it just picked up so that they are immediately clockwise of the destination cup. They keep the same order as when they were picked up. The crab selects a new current cup, the cup which is immediately clockwise of the current cup. Well, now I actually need to think a bit. Like I will not modify cups. I think I will return a copy because that's easier. Meaning. So this gives us the label of the destination cup, right? It doesn't give us the destination index. So first, let's write a quick helper to find the index of this value. Return I, panic. Because yeah, just panic if we can't find it. Because now we know that the destination cup needs to be in cups, we can just say D is search in cups for dest. Now D is the index of the destination cup in cups. And one thing that I find that is the thing that now irks me is we have to figure out, like, we need to keep track on what the last cup is, what the current cup is. So let's also say current is cups len cups -1, and let's actually do this up here. Hi Michael, that's fine. So that we can replace this. So we are doing crap games again with like rules that are convoluted. Not that convoluted yet, but they will get more convoluted, I presume. Okay, so the current cup is this. This should be a C. Then we determine the destination cup. We determine the index of the destination cup. And now we will just do... we will append to cups until destination cup the picked up cups. So then we will append to that the rest of the cups. And then, oh, now we need to rotate things. Okay, maybe there's a simpler way to do all of this. Is there a simpler way to do all of this? Because now we need to rotate it such that the starting cup is the current cup is at the end again. Which it is not necessarily right now. Wait, so this is actually, at this point, cups is the same. The last element of out is now the same as the last element of cups when we went in, right? Isn't it? Because we first added the cups. Oh no, this so this must be this first. The rest of the cups. Also the destination cup itself. This is everything up to the destination cup. Then we add the picked up cups. Then we append the rest of the cups. Yeah, and now the last element of cups is still the current cup, isn't it? Am I dumb? I think it's still the current cup. So this doesn't change. So we just need to rotate everything around by 1 bit. We need to rotate left. They keep the same order. The cup selects a new current cup, the cup which is immediately clockwise of the current cup. Yeah, I think we now need to rotate everything left. so we already know what the current cup is. The current cup will now be the first cup, right? Am I correct? Yep. Okay, so let's modify this. Let's say cow out starts with the current cup, and then we. This is. I find this code too ugly. I will not do this. This is too. We will think about it a bit more first. Okay, so what happens is. We have like 1, 2, 3, 4, 5. Let's start with this as a. So, and now 9 is the current cup. So we then we pick up these. We as the destination cup is now the one with a label to the current cup -1. So this would be, in this case, this would be the destination cup. And then we insert the first. We take out the first 3 and we insert them after the 8. And then we take the 4 as the new current cup. So yeah. Maybe I leave the code in after all, even though I find this horrible. I find this horrible. Something like a doubly linked list would probably be better right now, but. Okay, so just make an array of int. Okay, so let's just start from the beginning. So the first element will always be the current cup. So the next 3 elements will be everything up until the destination cup. I'm not even sure if the next element will not the first element will not necessarily be the current cup, because the current cup and the destination cup, could they conceivably be the same? Oh, why? Why? The current cup -1. No, we can't subtract 9 from that. Current cup and destination cup can never be the same. Okay, let's see. Let's start fresh. So, this one is, so, C is, yeah, you're correct. Okay, you're correct. Okay, so now again, this can't be so freaking difficult, right? We append to the picked up cups. Like, the only real question is, I mean, we can just be super dumb, right? We can just say. Can just like do everything the same way. We just say this is append to cups D, the picked up cups. Then we append to that, because like we don't really care about efficiency right now. We just the rest of the cups. And then we still have the current cup found. Now we just find the index of the current cup. In out the current cup, and then we want to have the next one after that be the last one. So we add 1 to that, and we take this modulo len out, and wait, why am I doing this? So we want to copy. Wait, do we want to copy? This is doing my head in, dumb shuffling. I still need to really understand what's going on first. So the destination cup is not one that we picked up, and it's not the same as, like, I'm wondering whether I'm overcomplicating things by, I know that I'm overcomplicating things. Also, I'm for some reason apparently, I don't know, super tired. Yeah, so the new current cup will be this plus 1, but because the current cup might be at the end, we need to take this mod len out, and then it might be 0. And now we want to make sure that index n is at the end. So we actually want to split yes, we want to move everything after n to the beginning, right? So we want to append to out until n. The value, okay, this doesn't work. The value n and no, everything before n and then the value n, right? So we take everything up till n. We first add n. No. Why am I? Everything after n gets at the beginning, then everything before n, and then n. It should be like this, I think. Yeah. Yeah, not efficient code, but I hope it does what we want. Let's I don't know. Let's check this out. Let's to track the current cup index rather than shuffling it to the end. True. Yeah, I think this is a good enough. This is a good enough argument to actually do that. Type game struct cups int cur int game get a game, return a game. Oh, not necessarily, because now we don't know that the first 3 cups are the... Yeah, but I think this is fine. This is probably fine. Let's start again. Let's always start again. Var next game. The crab picks up the 3 cups that are immediately. So I will just say func g game pick return g.cups I mod len g.cups. So let's just do this just for now. Okay, it picks 3 cups. Is this really easier? I can't believe that something like this, theoretically simple, is giving me so much trouble. I think it does make some things easier. It makes other things harder. But it's fine. Okay. Let's first, the destination cup is g.cups g.cur plus -1. And now we want to say if it's one of the cups after, because like now we can't just slice, because the current cup, like the next 3 cups from the current cup might cross boundaries and wrap around. But we can pretend that we can slice. and say out equals append out g dot cups from I. How do I want to solve it? I don't like any of this. I'm sorry that this is that I'm going back and forth and can't decide what I want to do. All solutions are ugly. I mod g len g dot cups. I will now do something. If for I plus plus, or actually we want to go from 1 to 4. If d, that's the label, is equal to g dot pick g dot current plus I d minus minus, and again we don't even need the counter. I don't know, something like this. No, we do need it. I'm stupid faced. D minus minus and continue loop. Right, because we want to now we want to check that the destination cup is not one of the picked up cups. I'm not super convinced that this is really simpler. Oh god, is this chaotic. I'm g dot pick d minus minus continue loop. And now we check again if it's one of them, and now we check again, and at some point this will break. Okay. Okay. I think this is fine. I don't know. I hope this is fine. Now D is the thing we want. So, or I called it dest before. Because now I have it by label, and now we say D is actually no. D is search for in g.cups for dest, and now we know the destination cup, and now we know the thing cup. Okay, var out int. So let's I don't want to start again, but this is just again, it's not, I don't think this is really easy. Because the index of the current cup changes. I don't know, maybe I'm just daft and just don't understand it, but anyway, out equals append, so best code, g dot pick the g dot cur plus 1, g dot pick g dot cur plus 2, g dot pick g dot cur plus 3. So this is the next three, the 3 cups it picked up. Then the next thing it will have is wait, what comes after that? Oh, the this will not be D, this will be dest. And now it will pick up all the rest that came after the destination cup. And this is not really simpler, right? Like, this is not just me. Oh god, I am. This shuffling around is. It's not supposed to be this hard, I'm pretty sure. Because everything can always like wrap around and do things, and I don't know. This is. Let's actually do this slice logic that I started doing. Let's do a like wrapping around slicing. So if j is less than the length of g dot cups, this is the easy case. Return g dot cups I to j. Otherwise, var out int out equals append, or we can also just otherwise take everything. Otherwise j is okay. I is modulo len g dot cups. J is modulo len g dot cups. If j is less than I in this case, this is if j is greater or equal I, so this is the easy case. Otherwise, out is append to a nil in slice g dot cups until from j to I. Wait, is this correct? No, from I to the rest, and then to that append g dot cups from 0 to j. Right, so this should now, like, we should be able to pass like any I and j in there. It will modulo it into like the right position. If the upper bound is still after modular arithmetic, if it's still above I, we can just take the normal slice. Otherwise, we take everything from I to the rest, and then from the beginning to j, and concatenate them together. And so this will give us sort of a pseudo slice in this ring buffer. Because now we can again say the picked up ones are like g dot slice from g dot cur to g dot cur plus 3, right? And now this loop will again be easier. For in PU, as long as dest is in PU, decrease dest. D will be search in g dot cups for dest. And now we want to say out is how do we start? Let's start with the picked up cups. I don't know. For now, we append to that the rest of the slices from the destination on to actually all of them, right? Like, yeah, now we can just slice from D to like from D plus 1 to D plus len g dot cups or something. Alex, no, we can't because the current ones are in there somewhere. I can't believe this is breaking me. This is so simple. But I'm broken. I am broken. I just don't have the working memory to keep in my head what is actually happening to this freaking thing. Okay. No, I don't think I can. Let's work, like, let's, I don't know. I really don't know how to. I mean, this really shouldn't be so hard. I find this incredibly embarrassing right now. Okay, so let's start with like something. Right, so let's say this is, we do the representation they use, right? Yeah, I haven't removed PU, exactly. And then also, like, I'm not sure where where the current game is, where the current thing is, and stuff like that. I never thought I would use this, but like, we can use this theoretically. I don't know. Yeah, I can't keep in my head like what is actually happening. So we go from the current cup, right? We determine the destination cup. So the destination cup will be, in this case, so we pick up these. This will be the destination cup. So, but so the next step will be like 5, 4, 6, 7. So everything from the destination cup till the end. And then then the current cup. No, it will be the destination cup, then the things we picked up, then everything from there till the end, and then the current cup. But, and like, this is kind of the issue, right? Like, this logic completely changes if we rotate things around. Like, what if like it's like this, right? So now this is the destination cup, and now we still start with the destination cup. And like, okay, so now, okay, so then we say, okay, everything from the destination cup till the end, and everything up until the current cup. So 6, 7, and then like the current cup. But like, now what if the current cup is actually like here, right? Like, what if it doesn't start here? Then like we start with there, right? And then you need to I can't picture it. I'm sorry, I just can't picture it. I think I will start again, just because I will start again, because this is what I do. And I will go back to saying the current cup is at the end, just, or something, I don't know. dest is current is cups len cups -1. Dest is c -1 for in pu dest minus minus. D is search in cups for dest. Right. Now, what do we need to actually do? The first one will be so we say out is I don't know. Out 0 will always we will start with D, then we can't believe this. I'm honestly like, this is where my brain just does not work like with as it should, like with stuff like this. So then we append everything we picked up, then we append everything after D in cups, and then we append everything up until D from cups, right? And now like at least this array should, like the slice should now be correct, right? So now so now now the slice is correct, but we do not know what the new current cup will be. But we can find the old current cup in the cups and add 1, and this will be like the new index of the current cup. So this is so far so good. Now, if we can fix this logic to work even in the case where, okay, no, let's just this can't be that hard. We append to a new nil slice just because we append everything after NC, and then we append to that everything before NC, actually everything up to and including NC. Is this right? NC is the next current cup, right? So we take everything after that and we move it to the front pretty much. Yeah, so I think this is right. I don't know. Let's check. Let's just write. Let's just leave it. Let's commit to this and let's check what happens. And this is super inefficient code and everything, but I honestly don't care right now. So we luckily we do have a lot of codes given, a lot of examples given, so let's just steal them. But we need to shuffle them around because our current cup is at the end. Oh, this was... pick up, destination, whatever. So this is move 2. And again, we will make sure that the new current cup is at the end. So we now have at least one test case. Let's first check that. Oops. Do move %v equals %v 1% v tc.in got tc.want go test. Nope. Okay, something went wrong. 5.4. So this is great. This is awesome. This is perfect. Basically, this is everything we want. It's just that we are missing 3 numbers. And they are the ones that got picked up. For some reason they are missing in the final product. Why are they missing in the final product? Because this should be out. And this should be out, and this should be out, I guess. Nope. No, we have a 0. I kind of feel like I don't deserve this, but maybe I do. Oh, we never append the destination cup itself. Nope, this is not it. New slice cups not out. Yeah, this. Yeah. Where's the 9 coming from? There shouldn't be a 9 anywhere in there. Why? Okay. Okay. Okay, let's see if this does what it... Okay, so destination to at 0. So is this ready? Okay, so first test case is passing. Yay! I'm so happy. But you don't sound happy. Well, I'm not that happy. Actually, let's do this. Because like the test cases we will now test will just be, we will just walk through the game that we have in the list. And see if everything, like if we make the same sequence of steps. I'm unfortunately not confident that passing this one test is enough, because there are lots of stuff that can happen. Oh, we also need to move this around. 3, 2, 5, 4, 6, 7, whatever. 8. Nope. The next state is 9, 1, 3, 4, 6, 7, 2, 2, 5. 7258. Cool. 679132584. Okay, let's keep it at that. For I 0, I less than len states -1, I plus plus. Got do move states I, if not reflects equal, did equal, got states I plus 1, should be line 12, point. I will look at that in a second. 5 should be at the end. Yeah, okay, you're correct. Thank you. T dot error f do move %v equals %v 1%v tc dot in got tc dot want. This is of course wrong. This is states I got states I plus 1. Needle not in slice. Cool. This passes. This does not pass. Okay. Line 78. Yeah, not helpful. Line 53. Okay, for some reason we can't find dest in cups. Why? How? What? Dest is, yeah, of course, I forgot the wraparound. If dest is less than 1, dest is 9. Doesn't panic anymore. Well, good that we have tests, I guess. Okay, I'm a bit more confident. Yeah, there are. Like, let's actually just go through all the states in this game again. Oops. Yeah. Everything wraps. 3, 6, 7, 2. Wait, I'm somewhere in the wrong line. So the last one was this one, I guess. So this is the next one. 3, 6, 7, 9, 2, 5, 8, 4, 1. 3, 6, 7, 2, 5, 8, 4, 1, 9. Uh, 5, 8, 3, 6, 7, 4, 1, 9, 2. 7, 4, 1, 5, 8, 3, 3, 9, 2, 6. Wait. I'm 7, 4, 1, 5. 741, not 5, 839, 2, 6, 5. And the last one, hopefully, 3, 7, 4, 1, 9, 2, 6, 5, 8. Needle, knot, and slice. Yeah, I don't know. Needle not in slice. You missed one. I missed a case. Yeah, this doesn't explain why needle is not in slice, because this should actually never happen, unless, oh, I guess unless I missed something else. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I missed one, obviously. Which one did I miss? 5, 8, 6. This one. This should be 7, 4, 1, 5, 8, 3, 9, 2, 6. Cool. It still panics, and it's not supposed to panic. So at what step does it panic is now the question. Let's do bisection. This half is good. This one isn't. This is good. This isn't. Is the case correct? Case width, this should be this one. No, yeah, 3, 6, 7, 2, 5, 8, 4, 1, 9. So yeah, this case is correct. Let's only do these ones. Cool. And add some debug logging and see why this doesn't work. Okay, so current cup destination 0. Why is destination 0? How can destination ever be 0? How can dest ever be 0? I don't... Oh, because if it's 0... Oh, exasperated. Absolute desperation. Okay, now at least the test game works. So let's leave it at that and see what happens if we pass the input. Oops. Oh, we should actually call this do move. How many moves does it do? In your list, the crab is then going to do 100 moves. For I is 0, I less than 100, I plus plus, cups equals do move cups. Film.println cups. Remember when I said that it would be so much simpler if the current cup was the last cup? Okay. Life hack. I don't know if this works, but Needle not in slice. 9, 5, 2, 3, 1. Yeah, yep. Oh. I'm tired. I don't want to live on this planet anymore. Does it eat this? Nope. My answer is too high. This is not. This is the least useful. Whatever. Using your labeling, simulate 100. What are the labels on the cup after cup 1? After cup 1. Yup. Let's try this again. Wait. In my thing, cup 1 is at the start. But my... okay. Should I rewrite everything to instead use the first element as the current cup, which is what they intended and which is probably gonna make my life easier? I think I should. I don't want to, but I will. I think I should. Luckily, the test cases almost don't change. And now this will be, you will see, this will just make everything just work. Okay. Do moves. So we will still do exactly the same thing. Pickup and cups will be cups, but in this case it will be, pickup will be everything from len cups minus 3 onwards, whereas cups will be everything until len cups minus 3. Nope. Pickup will be this, and now we can't use cups anymore as a slice. I am so tempted to go back to ring buffers. Technically speaking, for the record, I should also catch like -I at this point, but I'm not gonna bother. Am I not gonna bother? Yeah, I'm not gonna bother for now, until I see that I need it. It's not technically going to be a slice, it will be a copy, but whatever, we are fine with that. The same as before, if j is bigger or equal than j. Like, technically speaking, this logic doesn't break, like this logic breaks if I then try to slice from I to I plus 10, but that's fine. Return R from I to j, otherwise return append ring nil, everything up until j, everything, and then append to that. Yeah, sorry, I don't know, I don't want to live on this planet anymore. It's just, I don't know. Uh, cups.slice everything from 1 to 4. Cups.slice everything from 4 to 1. 4 to, I guess, 4 plus len cups. Nope, 1 plus len cups. I don't know. I don't know. I don't know what I want to do. I'm so frustrated. This shouldn't be hard, but I find it super hard. I don't know why. I mean, I mean, I mean, technically, I should be able to just reorder the stuff to what it was, like, to what they expect, right? Like, no, I didn't undo enough, or I undid too much. Oh, I broke it again. Shouldn't be so hard. What am I, like, where am I going wrong with everything? I'm frustrated enough to just throw everything away and start new, but like I've done it 15 million times already, so. Okay, so now I'm again at the state I was previously in. So this is what I get, but like what they actually want to see is this, right? So, and now they want to see everything after the 1, which should be this. It's not the right answer. I think I need a break. I will take a 5-minute break. This is fucking me up. Sorry, see ya in 5 minutes or something. Okay, I guess we see. I thought I would just try, like, with less pressure to do a bit of a rewrite with like ring buffer stuff. And so now I have this ring type, which supports all the operations we kind of need. It has indexing, it has the same slicing we had before, which I think is still correct. Like I did a rewrite offline and thought I would just now walk you through it, but it still doesn't work. So we will see how to debug this. It still has the same slice operation it had before, and it does exactly the same if. Oh no, this isn't right. This should be this. Still doesn't work, but now at least the stuff is a lot smaller. 9, and the order seems, at least in this operation, the order is correct. Right, like this is 915, 915, 467, 328. Yeah, so maybe there's just like some shifting shenanigans going on. We will see. Okay, so this append now works. Now searching for stuff are methods on ring, but like the logic is exactly the same as before. And I added this function, and this is something I want to check, because this looks like this is what's currently wrong. Shift rotates the ring around to make n the first index. This is what it's intended to do, what it intends to do. And we take everything from n on, and we append everything until n to that. This does look correct. The order of elements is still the same. This just shifts n to be the first element, right? We can write tests for all the things separately if we think this doesn't work. But let's first walk through the code. So it does exactly the same. So we first get the current cup, which is now the first element of cups. We now do the circular slicing. So we first take the from element, like the first 3 after the first one. So from like element 1, 2, and 3. This is this slice. And then the rest of the cups will be the rest of the thing. Like we slice from 4 to 1. Oh, this shouldn't be, should this be? No, this should be including 1. Yeah, this shouldn't be excluding 1. Wait, should this be, this should be 2. Shouldn't it be? Oh, no, yeah, the highest element that is included is the 0th element. This is correct. Right, yeah, so, right, so this will take, like, if we have, and if then the first one will be the target cup, the first slice will be these 3, and the other one will slice from the 4th element, which is 5, and go around until including the 0th element and like excluding the first. Yeah, so this is actually correct. Then we do the same destination logic we had before. We say if we have like decrement dest until we don't have it in picked up, we search the index of the and of the destination, and then we build a new ring. We first add the destination thing, the destination element, then we add everything we picked up, then we add everything else in the ring. So this slices from the element after d+1 to excluding the destination element from cups. So this is everything except the destination element in cups, which is, well, the only thing left that is still in cup. And appends that, and so this should be the correct order, right? And then we still need to rotate it so that the new current cup is at the 0th element. And for that we find the previous current cup, which was C. We add 1 to that. Oh, wait, do we add 1? Yes, we add 1 to that as the new element. And we take, we don't want to take the value at, we want to shift to that thing. So we actually want to return out.shift to this element. And then we need to make sure that out.shift also does a n modulo len r to make sure that this always works. And now the tests pass again. Great. Yeah, I did also off-screen fix the test cases to have the correct format with the correct thing at the beginning. So now this is actually in the order that they expect, like that they, yeah, like this will also always have the current slice at the beginning. I think what's the problem with, like, because if I now run this on the input, right, I will still get the same thing I previously got. And I think this has just occurred to me that this is the problem. I'm not happy about that because it means I need to do weird things again. No, this is gonna be fine. I think this is gonna be fine. So the issue with this is that if you look at the, like, I think they expect you to, like, you start with the current cup at the first element, but they then expect you to actually keep track of the position in the current cup and not rotate the thing around. So we do actually need to keep track of the current cup separately and not always shift it to the 0th element. But I think that it should be relatively easy. And so, like, our order is completely screwed up because well, we, like in this example, we would start with an 8 and we want to start with the 5. And so the actual solution will just be like some suffix of this. But because it will be like somehow rotated. But let's actually solve the problem as intended and not go through, like just go through all suffixes and just trial and error them. And I think this should be probably doable. So we will go back to the having a type game, which has a current cup and the cups, which will be a ring. And now we will take a game and return a game. So, and now, actually one thing I would like to do, I think, because otherwise I will go mad if things go wrong again. I will at least git add it. I will not commit it yet, but I will add it to the index so that I can always just go back to this state where I at least know it does the right thing, and I don't go mad with undo things again. Okay, so basically what we now want to do is we want to change all of the relative to 0 stuff to be relative to the current stuff, the current index. So we just want to say g.cur here. We want to say g.cur plus that, g.cur plus 4, g.cur plus 4, g.cur plus 1. And like, because we now have just the whole index management thing with wraparound handled, this hopefully will just work. And so this logic doesn't change because this is value logic. This is also, like, this also doesn't change. This also doesn't change. This also doesn't change. This also doesn't change. And so var ng will be a new game. And then so cur is the I should actually write that down. Index of the current cup, and this will be cups. Now the next game ng will be return game, where cur is gonna be out.find c plus 1. And I guess like mod len out, but like I don't think this matters. And cups will be out. And like now we don't even need to shift them around because now we no longer assume that the current cup is the first cup. Apart from that, I think the logic should be fine. Cannot use do move cups. Yup. G is a game with cur being 0 and cups being cups. This is concerning that nothing changed. Right. Cups states I. Let's start with this. States I, got states I plus 1 I. Okay. Yeah, now this isn't reflect equal anymore. And this should be now we need to rotate the tests around to actually be okay. So this is actually less straightforward than I was hoping, but we will see. And so let's see, we actually need to rotate them around. We should rotate them around to actually have the same order that they have here. Why anyway. This is too hard to read. I don't know why, like what GoVim is trying to tell me by sometimes highlighting certain words. So this will be index 1 and the 3 will shift here. This will be index, this will be the 5, so this will be index 2 and the 3 and the 2 will shift up. This will be index 3 and the 7, the 2 and the 5 will shift up. This will be index 4 and the 3, the 2, the 5 and the 8 will move up. This will be index 5. Yeah. Actually, in this example, the cup just always rotates around. But I don't think it does have to do that in general. I'm not sure if it has to do that in general. It might. 9, 2, 5, 2, 5, 8, 4. 9, 2, 5, 8, 4. Yep. 6, and this will remove the first 5 elements, the last 5 elements, like these elements here. This will take 6 elements, 6 elements over to this thing, this side. Is this correct? 2, 5, 8. No, this is not correct. I screwed up something, the order. So 3, 8, 9 to 7. Okay. 3, 2, 8 to 7. 3, 2, 5 to 9, 1. 7 to 5 to 6. 3, 2, 5 to 9, 1. Okay. Move 6. Is this one? 9, 2, 5, 8 until 7. Move 7, 2, 5, 8. Nope, this is 7258. And then move 8 is 836, 36. And now 8 will have the 6 at the end and be otherwise the same. And then we start with 0 again. And then the final state will be 1, and it will have the 5 shifted down. And then we can actually say we actually can do this, and this should... Right, let's see. Of course, now it complains because we don't care that our thing always goes and the cup's values are the labels as they appear moving clockwise around the circle. The current cup is marked with that. So like they just always increase the current cup by 1. But because we shift things around, we need to, we are doing things differently. Our game is this. I think our game is probably the same. It's just that, like, okay, so is the order the same? 28915, 28915, 4673. Yes, and like they have 1 as the current cup. We have 2 as the current cup. So like even though our game state is the same, it's rotationally symmetric to the like we just moved it around, but like we still mark the same thing as current cup and the same thing as the new cup. But because they just like they use this logic where basically the current cup just like they rotate it so that the current cup is just increasing an index by 1. And we just rotated whatever makes sense in our code. We don't have the same order, which means we don't get the same output, because even though the game state is rotationally symmetric, and I guess just shifts around, like their output, the output they expect isn't, because it depends on what the current thing is. And I don't like this problem. This is day 20 all over again. Just even more embarrassing because it's like not even like it's just shuffling stuff around. What are the labels on the cup after? So we can, what we can now do, I guess, is we know what, we can calculate what position they expect the current cup to be in, because it's just 100 modulo the number of cups, so modulo 9, so I guess it's 1. They expect it at 1, and we have it at like something else. Let me actually output. Oh, this is why we didn't get a change. Because we just print cup. Yeah, so we know that we actually want to have the current cup to be 8. So we can just cheat and try to, like, not cheat. We can rotate the ring to make 1 the current cup. So we can try to say, so our current cup is 8. we want the current cup to be 1, so we want it to shift 7 to the left, right? So we want to make index 7 the new 0. So we want to make the current cup minus 1 the new 0. So g dot cups is g dot cups dot rotate g dot curl minus 1. And now this is the first time that we subtract indices. So just to make things have I mentioned that I'm not entirely, oh, it's not rotate, it's shift, convinced about Govim. Just to be entirely accurate, if n is negative, this will fail. So what we will instead do is we will say, because a negative number modulo something is a negative number and we want it to be a positive number, so we say this is n modulo len r plus len r. This will now be a positive number, because even if it's a negative number, it will be like the absolute value will be at most minus len r, I guess. So this is now a positive number, and now we take this modulo len r again, and this is now the what I would call the actual modulo thing, because for me a mod b is always non-negative. It will always be between 0 and mod plus 1. And like this math is super complicated, like looks super complicated and is relatively expensive, but it is what you have to do to get that. Even though it still doesn't work. Wait, why? We try to shift 7 to be the new 0, and it, of course we also need to do g dot curl is 1. Yeah, so I think this is the state they actually want to be in, and this is of course super cheated, but let's see, let's hope. No. I've been at this for almost 2 hours and I still don't have anything. Why? But like, simulate 100 moves. So maybe they want 2. Maybe they don't want 1. Okay, if I simulate 1 move, curl will be 1. So if I collect the other cups labels clockwise into a single string with no extra characters. Each number, they don't, fuck me. Sorry for cursing. No, but like I tried this before, right? I tried this. This is every number except 1 in clockwise direction, and they didn't accept that either. No, now they, maybe I didn't try it. 2 hours to get 1 star. I can't believe it. I just don't want to believe it. Starts arranging many cups in a circle on your raft. 1 million in total. Your labeling is still correct for the first few cups. After that, the remaining cups are just numbered in an increasing fashion, starting from the number after the highest number in your list and proceeding 1 by 1 until 1 million is reached. Now, for example, if you're labeling, I will not do this. I'm too frustrated and too puckered out. I just refuse. I can tell, like, now the thing is, oh, if you implemented it inefficiently, this will now break, but, well, yeah, my code is super inefficient, but I just hardly got it to work at all, and I'm not interested in optimizing that. I refuse. I'm too frustrated and angry at all of this. The cups would be numbered and then start counting up from 6 until 1 million is reached. In this way, every number from 1 through 1 million is used exactly once. After discovering where you made the mistake in translating crab numbers, you realize the small crab isn't going to do merely 100 moves, the crab is going to do 10 million moves. I mean, like 10 million and 1 million, they are not that large numbers, but like if you have to do like a million times 10 million, this is going to be annoying. It's going to hide your stars, one each, under the 2 cups that will end up immediately clockwise of cup 1. You can have them if you predict what the labels on this cup will be when the crab is finished. In the above example, this would be this and then that. Multiplying these together produces that. No, I will not do this. I will just stop it here and I will table flip out of here because apparently I'm too dumb for this. This is too frustrating and I will not make this more efficient. So I will just stop here and I will hopefully try again tomorrow. I would actually like to get all stars eventually, like before the end of tomorrow, but I might not. I still haven't done the second star for day 20 and I don't know if I will do the second star here. So thanks for watching, I guess, and maybe see you tomorrow. We'll see what happens.